Friends, today we are going to discuss the next chapter, that is elimination reactions. So what is meant by the elimination reaction? So elimination itself indicate we remove the atoms or groups from the reactants and to form a products which having the higher degree of unsaturation. So means what? From the reactant we remove the two atoms or group of atoms and then we get a product. So product having the higher degree of unsaturation, and such type of reactions we call the elimination reaction. And when we think about the elimination reaction, then here we think about the 1-2 elimination. 1-2 elimination reaction means what is meant by the 1-2 elimination? 1-2 elimination means the groups or atoms which is removed from the carbon number 1 and carbon number 2 or adjacent carbon. So that's why these reactions we call 1-2 elimination reaction. We take one simple example and we take this is your substrate or reactant, and then what happen, we call the carbon number, this is the carbon number 1, or we call the alpha carbon, this is a beta carbon, or we call the carbon number 2. And what happened in this case means this is living group, this is hydrogen, means that carbon number 1 or alpha carbon there is a living group X, at carbon number 2 or there is at a beta carbon there is a hydrogen is there, and when these two atoms from adjacent carbon or carbon number 1 and carbon number 2 they are eliminated, and there is a formation of products which having the higher degree of unsaturation. So this is called the 1-2 elimination. Means why we call the 1-2 elimination? Because the groups from carbon number 1 and carbon number 2 or adjacent carbon they remove, so that's why it is called as a 1-2 elimination reaction. Then again we take another example of 1-2 elimination reaction. Suppose we take this is the example, and suppose we take this is hydrogen. Again these atoms we remove, and again we get the products which having the higher degree of unsaturation. So that's why here we take, this is the first example, this compound is a saturated one. After 1-2 elimination we get unsaturated compound. Here there is a 2 carbon-carbon double bond is there, and what happened, this compound is unsaturated, but after elimination we get the degree of unsaturation is increases. Here is a carbon-carbon double bond is there, here is a carbon-carbon triple bond is there. So in both the cases the elimination is takes place, and group from carbon number 1 and carbon number 2 is removed. So that's why it is called as a 1-2 elimination reaction. Once we discuss the 1-2 elimination, then we want to discuss the next point, that is the beta elimination. And we know what is meant by the beta elimination. Means we take one simple example, and suppose we take this one, and what happened when we do the eliminations, we call the 1-2 elimination, or here we call the beta elimination. We call this is alpha carbon, we call this is beta carbon, and the living group which is present on that carbon we call the carbon number 1, or either we call the alpha carbon, and at beta carbon there is a hydrogen is removed. So what is meant by the beta elimination? Means at beta carbon we want to remove the groups, and suppose this group is a hydrogen, then we call the beta elimination reaction. Means at alpha position there is a, or alpha carbon there is a chlorine, chlorine is living group, this group is removed from the alpha carbon, and the hydrogen we remove from the beta carbon, then all such type of examples or reactions we call the beta elimination. So this is the example of beta elimination. Means at a beta carbon we remove the hydrogen, and means at a beta carbon we remove the hydrogen and then the elimination takes place. So that's why we call the beta elimination reaction. So all the beta elimination reaction is an example of 1,2 elimination, but all the 1,2 elimination is not example of beta elimination. So that's why we remember what is meant by the beta elimination. Means in an elimination reaction we remove the hydrogen from the beta carbon, then such reactions we call the beta elimination reaction. And we remember beta elimination reactions is the example of 1,2 elimination reaction. Once we discuss this, then what is the mechanism of elimination reaction? So we think about a mechanism. And when we think of mechanism, then we take a simple example. Again, this one we call the beta elimination or 1,2 elimination. Yes. And when the reactions takes place, then we remember what happened. This is alpha carbon, this is the beta carbon. And when we see, when the product formation takes place here, and when the product is formed, then we get your alkene as a product. And when we get alkene as a product, then what happened here? The bond between the three things which are happen in the mechanism of elimination reaction. The first thing, breaking of C alpha and we call the X bond. This is one thing is happen. The bond between alpha carbon and leaving group or X is break. Then second thing, we remember the breaking of bond between beta carbon and hydrogen. So what happened in second thing is happen in a elimination reaction or mechanism of elimination reaction. Bond between this beta carbon and hydrogen is break. So the breaking of the beta carbon and hydrogen bond. And in third thing which has happened, and this one, the formation of pi bond between the alpha carbon and the beta carbon. So this is a simple three things which is happen in a elimination reaction. This is simple example. We know what happened. The breaking of bond between alpha carbon and X or leaving group is break. So the bond between alpha carbon and X or leaving group is break in elimination reaction. Second thing is happen, the breaking of the bond between beta carbon and hydrogen. So this is the beta carbon and hydrogen, this bond is break. And third thing is happen here, the bond between this alpha carbon and the beta carbon. So the pi bond formation takes place. So means the pi bond formation between the alpha carbon and beta carbon. So these three things which has happened in a elimination reaction. And when we think about this elimination reaction, then we remember that depending on the sequence of breaking and formation of bonds, means in elimination reaction three things are happen. This bond is break, alpha carbon and leaving group. The bond between beta carbon and hydrogen is break, and pi bond between the alpha and beta carbon formation takes place. So depending on the sequence of bond breaking and bond formation, these elimination reactions categorized into three types, and this one we say E2 elimination, E1 elimination and E1CB elimination. Mean just now we discuss what is the sequence of bond breaking and bond formation in a mechanism of elimination reaction. Depending on that, this elimination reactions is categorized into three types, or having the three types: E2 elimination, E1 elimination and the E1CB. E2 elimination means elimination bimolecular reaction. E1 means the elimination unimolecular reaction, and E1CV means the elimination unimolecular proceed through the conjugated base. And when we want to know this elimination reaction, so we see the one by one, and first we consider the elimination, E2 elimination. Or this E2 elimination is called as a bimolecular. Bimolecular reaction. So what happened in case of E2 elimination reactions? So this is the bimolecular reaction. And what happened when we take a simple example of this, and we write this. This is your living group. This is a alpha carbon. This is a beta carbon. When we do the E2 elimination, this is the first step. It is a slow step, and we use a base. We know in elimination reaction we use a strong base, and suppose we use this base, then what happen? The base is abstract the hydrogen, then the bond between beta carbon and hydrogen is break, and simultaneously the bond between alpha carbon and Y or living group is break, and we get a transition state. So this is simple E2 elimination. What happen? You take substrate, we use a strong base, then formation of transition state. It is single step reaction. First step is a slow step. Base is abstract the proton, so bond between the base and hydrogen is formed. Simultaneously the bond between these beta carbon and hydrogen is break, and simultaneously the bond between pi bond between the alpha carbon and beta carbon formation is takes place, and again the bond between alpha carbon and living group is break. And once there is formation of a transition state, and this transition state simply convert into the product. So what happened in this is a simple example, and we call the E2 elimination reaction. So what is the characteristics of E2 eliminations? It is called as a bimolecular reaction. And why it called as a bimolecular reactions means the rate of reaction is depends on the substrate as well as the base. Because base is abstract the proton in a slow step of the reaction. It is single step reaction. Both the molecules they are taking part in a reaction in a slow step. So this is substrate as well as the base. So that's why it is 2 stands for the bimolecular reaction. Means the rate of reaction in E2 is directly proportional to the concentration of the substrate as well as the nature of substrate as well as the concentration and nature of the base. So this reaction is a bimolecular. Then what happened in this case? It is a concerted. This reaction is a concerted, and again this reaction takes place in a single step, and it proceeds through the transition state. So this is the characteristics of the E2 elimination reaction. It is a bimolecular reactions because what happens, the rate of reaction is depends upon the substrate as well as the base. It is a concerted, means the bond between alpha carbon and living group, the bond between the beta carbon and hydrogen is break, and simultaneously the bond between alpha carbon and beta carbon formation takes place. So this is a concerted process, means all bond formation and bond breaking takes place in a simultaneously. So that's why we call E2 is a concerted as like a SN2. Because we already discussed the SN2 mechanism, substitution nucleophilic bimolecular, and in SN2 also, SN2 reaction is a concerted, E2 reaction is a concerted. In SN2 there is formation of transition state, in E2 there is a formation of transition state. SN2 reaction is a single step, the E1 reaction is also the single step, and the E2 and SN2 is also proceeds, both the reactions proceeds through a transition state, and transition state is cleaved into the product, and there is formation of a product. So this is simple example of E2 elimination, it is called the bimolecular reaction. Then you take a next type, and we call this is a E1 elimination. It is these reactions we call as a unimolecular reactions. Means the rate of reaction is depends on only the single molecule, or that is a reactant. You take this is simple example. This reaction proceeds through the two steps. What happen in case of, we say the E1, here we use the base, then this is the first step, and this first step is slow step, or we call rate determining step. What happen in case of the first step? There is a bond between alpha carbon and leaving group is break, this type, and there is a formation of carbocation. There is formation of a carbocation. Similarly, what happened in case of the SN1? In SN1, in first step is a slow step, and there is formation of a carbocation. So similarly in E1, there is a formation of a carbocation. Once the carbocation is formed in first step, then what happened? In second step, the base is abstract this proton, and there is a formation of a carbon-carbon double bond, and we get here the product. This is second step, and second step is a first step. So in this way, this is the mechanism of E1 elimination. So why we call the one stand for the unimolecular, means the rate of reaction is directly proportional to only the, that is a substrate or starting compound, or it is a reactant, but the rate of reaction is not depends upon the base. Because what happened, which is the first step? First step is a slow step, and in slow step what happened, only the reactant is taking part in the reaction, or this substrate is taking part in a slow step, and there is formation of carbocation. So base is not taking part in a first step, or which is in a slow step. So base is abstract the proton in second step, and there is a formation of your product. So in second step is a fast step, and in fast step base is attack on, or base is abstract the proton in a fast step, and which is the second step. So that's why rate of the reaction in E1 is not depends on the base. So what is the nature of the base, as well as the what is the concentration of base, the rate of E1 elimination or rate of E1 elimination is not depends on which type of base we use, because base is attack or base is taking part in a reaction in a second step, and which is a fast step. So this is a simple mechanism of E1 elimination. Then again, what is the characteristic of this E1 elimination? It is a unimolecular reaction. One stand for the unimolecular. Then what is the second important point? There is formation of a carbocation. And then what happened? What is the next important point? It is a two steps reaction. So when we compare the SN1 and E1, there is a similarity between E1 and SN1. So what happened in SN1? Formation of a carbocation. What happened in E1? Formation of carbocation. The SN1 is the two steps. E1 is also the two steps reaction. Again, what happened? The rate of reaction in SN1 is totally depends on the substrate. So similarly, rate of the reaction in E1 is depends on the substrate, is not depends on the base, because base is attack in a second step, and which is a fast step in the reaction. Then we take a next example, and this is called the E1CB. This is the last type or third type of elimination reaction, and we call this is a E1CB. So we call elimination unimolecular proceeds through the conjugated base. We take the simple example. This reaction having also the two steps reaction. We take this is Y. This is the alpha carbon. This is the beta carbon. Then the elimination reactions are takes place. We call the E1CB, and these reactions having the two steps, and we use the base. This first step is a fast step here, and in case of the fast step, there is a base is abstract the hydrogen, and there is a formation of the carbanion. There is a formation of a carbanion, and once the formation of carbanion, or we call this is a conjugated base. And so that's why once in first step formation of carbanion is there, and in second step what happened, there is a formation of a product. Once the carbanion is formed and these electrons are given to here, leaving group is leave out, and this is the second step, and we remember there is a formation of a product is there. So it is a simple example of the even CB. So what happened here, the base is there, this is a substrate, first step is a fast step, and base is abstract the proton. Suppose we take this is the base is abstract the proton, and there is a formation of a carbanion at beta carbon. So beta carbon having the lone pair of electrons, so that's why we get this carbon having the negative charge, and when the carbon having the negative charge we call the carbanion. And once the carbanion is formed, or we may be called the conjugated base. And once the conjugated base is formed, then these electrons are given to here, then the leaving group is leave out, second step is a slow step, and then there is a formation of a product, that is a alkene. So this is simple third type of elimination reaction, and we call even CB. Elimination unimolecular proceeds through the conjugated base.